Jai Hind carrots. Let us see next type of partial fractions. Already we have seen rule 1, 2, 3, 4. These are all under proper fraction. When the given rational function is proper fraction, then you apply any one of the rule. Here we have the fraction, the rational function which we have is improper, right? What is proper? The numerator's degree is less than the denominator's degree. Then what about improper? There are two cases in improper. One is the degree of the numerator is equal to the degree of the denominator, and the case 2 is degree of the numerator is greater than the degree of the denominator. Okay, first let us see case 1. Degree of f of x is equal to degree of g of x. Okay, I am considering an example here. X squared by 3x minus 1 into x plus 2. Okay, then generally how do you do the division? Suppose if you have 7 by 2, right, you are doing the division with 2. 2 times 3 is 6 and the answer is 1. This is quotient and remainder. So 7 can be written as 2 into our quotient plus r. Quotient into our divisor plus remainder, right? So here we are dividing our f of x with what? With g of x. So into some value should be, we have to get some value, and some remainder also we have to get, right? Let us see which type of remainder do we get and which type of quotient we will get in this case. See, x square is dividing with this one, that is 3x minus 1 into x plus 2 is going to divide the x square. See, 3x into x, we are supposed to get x square here, first term, right? So 3x into x, 3x square, of course you have x square here, 3x square you are having. To get only 3x square, what do you do? If you multiply with 1 by 3, what you will get? X square, right? So what about our quotient? We will take it as 1 by 3. If we multiply this with 1 by 3, our first term will be x square. Of course, remaining you will get terms here. Okay, then x square terms gets cancelled, and the remaining will be the remainder. And once you observe two things here, what will be the quotient here? Constant. How that constant you are getting? A linear factor. If suppose every linear factor's quotient is 1, no need to take the number. We have to consider only 1. If you have any value, 3 suppose, here you have 3, you are getting 1 by 3. If you have 2, you will get 1 by 2. So this x square can be written as our quotient 1 by 3 into this value 3x minus 1 into x plus 2, and the remainder also you will get some x so and so, right? So r of x you will get. It is also a function of x, r of x. And this r of x degree must be less than 2, right? Already x square term gets cancelled. So definitely you will get less than 2 only. So r of x degree definitely the degree of the less than the degree of the g of x. Right? You have to consider these 2 points. One is constant. So here, whenever you have two degrees are equal, there exists a unique constant k like this, such, and a polynomial r of x, such that f of x is equal to k into g of x plus r of x, where our degree of r of x is less than degree of g of x. So hence, if you divide this with g of x, what do you get? Our rational function you will get f of x by g of x is equal to k plus r of x by g of x. Okay, here only the thing you have to remember is what will be the quotient. Now, hence what you write? X square by 3x minus 1 into x plus 2 is equal to 1 by 3. This term will get cancelled, plus r of x by 3x minus 1 into x plus 2. In this example, the degree of r of x is definitely less than 2, right? then degree of the numerator is denominator is 2. So is this a proper fraction or not? Yes, absolutely it is a proper fraction. Okay, this is a, when you are dividing this means you are supposed to get proper fraction. Then you can apply any rule, rule 1, rule 2, rule 3 and rule 4. Okay, here let us see this. So hence from that idea, how do you write this? X cube by this one means what will be the constant here? 1 by, any constant exists here? 1 only. Here 1. But here what do you have? 2. Right? 1 by 2. Plus r of x by, again you will get a proper fraction. And that proper fraction can be taken as, here all are linear factors and not repeated. Right? So a by 2x minus 1 plus b by x plus 2 plus c by x minus 3. And then again by taking LCM and again we will solve same as it is in the previous questions. Okay, let us solve it. By taking the LCM you will get denominator parts gets cancelled. I am writing directly here. 2x minus 1 into x plus 2 into x minus 3 plus 2 into a into x plus 2 into x minus 3 b into, how much? Only you have x plus 2, but you have to get all the things, right? So here 2b into 2x minus 1 into x minus 3 plus 2c into 2x plus 1 into x plus 2. Then again by simplifying it and comparing both sides you will get ABCD values, and that ABC values you substitute here, hence the answer.